This video goes with Kuta handout number 20. It's actually solving equations, but when you look at where we're going to get started, we're going to do some review before we actually start to solve equations. And the first thing that I want students to refresh their memory on is combining like terms. So in problem number 5, if I would like to put terms together that go together, I would notice that a positive x and a positive 6x, they would go together. They're like terms. And of course, numbers we can put together, a positive 1 and a positive 6. Those become like terms also. So let's do the variables first. A positive x and a positive 6x become a positive 7x. A positive 6 and a positive 1 put together is a positive 7. And of course, I cannot combine those two terms. Remember, for like terms to be combined, you have to have the same variable, same exponent. So of course, this term has a coefficient of 7. But that doesn't matter. It has to have an x to the first power for me to combine it with something else. So this is as simple as it gets. We're going to leave it as 7x plus 7. Problem number 6 starts to talk about the distributive property. We need to multiply that positive 7 through the parentheses. So I'm going to do it first. Positive 7 times a positive 6n becomes a positive 42n. A positive 7 times a positive 5 becomes a positive 35. Once again, I can't put those two terms together. They're not like terms. Let's move on to problem number 7. A positive 3 times a positive 3 is a positive 9. A positive 3 times a positive 5b becomes a positive 15b. And now combine those two terms. They're not like terms. Over here, I'm going to multiply the 2 through the parentheses. Positive 2 times a positive 2 is a positive 4. Positive 2 times a positive 7b is a positive 14b. Once again, we can't put those together. They're not like terms. So once the students complete the first side of the handout, it should be easier to move on to the second part of the handout because we'll be using some of those same skills to try to solve equations. So I'm going to do a couple examples here. And I always think it's a good idea for students to draw a dotted line right down from the equal sign so they can see both sides of the equation. And when I look at the left-hand side, I notice that I can put together a negative 3n and a positive 5n. Those are like terms. And if I do that, I get a positive 2n equals, and of course on the other side, I can't put together a negative 10 and a positive 4n, so that stays as a negative 10 plus 4n. I want to try to get all the n's on one side of the equation. Well, it should be obvious that we should move them over to the left because then they'll all be over here. So I'm going to go ahead and see if I can get all the n's on the left-hand side, which means that this has to go away. So what's the opposite of a positive 4n? Well, it would be a negative 4n. We need to do the same thing here. And then, of course, in mathematics, we do this sum line, which just means we're going to put things together and simplify. Well, a positive 2n and a negative 4n put together is a negative 2n equals, and on this side, I still have a negative 10. And of course, a positive 4n and a negative 4n cancel. I don't have to put plus 0. Once again, now I have one step to go. I need to get rid of the negative 2 next to the n. Well, in math, this implies that we'll be multiplying. So what's the opposite of multiplying a negative 2? Well, let's divide by a negative 2. Remember, a negative divided by a negative becomes a positive. And of course, 2 over 2 is 1. So here's my 1n. And we never really put the coefficient 1 there. We just put the letter n. That stands for 1n. And do the same thing over here, divide by a negative 2. A negative divided by a negative is a positive, and of course 10 divided by 2 is 5. So what does n equal? Well, n equals 5. That means that if I replaced every variable in the upper or the beginning equation with a 5, both sides of the equation would equal each other. When we look at problem number 16, I notice that even if I draw my line and write down the equal sign, I'm thinking that over here on the left-hand side, I can use the distributive property to kind of simplify some things. So I'm going to do that first. Multiply that negative 6 through the parentheses. So a negative 6 times a negative 4 is a positive 24. A negative 6 times a negative 2r becomes a positive 12r. And then that's going to equal, and on this side I have 24 minus 5r. I can't simplify that side of the equation. So when I look at this, I'm looking to see if they're identical each side of the line. If it's an identity, that means all numbers will work. I notice here that it's not identical on each side, so I'm going to see if I can simplify and try to get all the variables on one side. I'm going to try to move them over here to the left. So positive 5r will get rid of that over there. I do a positive 5r on this side of the line. And then, of course, my sum line, I just want to kind of see what's going to happen here once I put things together. So let's see, 24 and nothing is still 24. Positive 12r and a positive 5r put together becomes a positive 17r equals, and of course over here I have 24, and nothing is 24, and a negative 5r and a positive 5r, they cancel. As I keep going here, let's see, I want to get r all by itself, so I'm going to do a negative 24, do the same thing over here, a negative 24. Remember, we try to save the coefficient of the variable for last. That's always the simplest thing in mathematics, the simplest way to approach a problem. Positive 24, negative 24 cancel. I have my positive 17r equals, and over on this side these cancel, but I got to put a 0 there as a placeholder. Well, I can stop right here. You know, even if I divide by 17, r has to equal 0 for this to work. Kind of ran out of room there, so I'm going to put my answer off to the side. But the only number that would work is when r is 0 for both of those to be the same. I think I'll leave those two examples as good examples to help the students with all the problems on the sheet.